Hello guys, welcome back to part 3 conversion factors. This is the third part of a series of 3 videos explaining conversion factors from scratch. So if you want to learn this skill, if you master it, I highly recommend to go to part 1 and part 2 and then stick with me in part 3. I am Andres, IB chemistry teacher in an international school and IB examiner. I also recommend you to subscribe to the channel if you haven't, and you will be informed of new practice papers, different exercises and topics. I am explaining all the syllabus. So start, I want to show you first what you are learning, maybe if you have doubts. The thing is that by using conversion factors, you don't need to memorize any formula. You will save a lot of time solving them, especially using dimensional analysis. Improve your confidence when approaching these kind of exercises. When you are facing challenging exercises with different formulas, this is an excellent method. And this is something that you don't need to apply only to chemistry. This is also applicable for physics, math, and even your daily life. Let's start it. In this three part of conversion factors, we will talk about derivative units and or compound units. In this, we are involved two or more quantities in ratio from, for example, we have a speed, molar mass, or density. These are derivative or compound units. Okay, so for example, here in density, this is very well used, not only in DP, but also in MYP. We have done the density is the mass over the volume. We are talking about 2 units, and also we can solve exercises that have this kind of units. Here we have, for example, concentration. That will be the number of moles over volume. We have distance over time, and we have the respective units. This is very important that we need to keep in mind the units, and this is one important thing for dimensional analysis and for this approaching of conversion factors. Let's start with this exercise. It says we have this equivalence or this formula that is density is the mass over volume. It's easy, and I will tell you that even though this is a very formula to remember, because I'll applying the conversion factors in this scenario, you don't need to. We have a liquid has a density of 1.25 grams over centimeter cubes and a mass of 500 grams. The density is given and the mass is given here. Calculate the volume of the liquid. We need to calculate the volume of the liquid in centimeter cubes. Always my starting point when I am using conversion factor is the number that is given. In that case, 500 grams is given. So this is the starting point. So if I will trace a line and I will use the equation. I will use what is given as a unit. So density is given here. In the density, they are telling us that we have 1.25 grams in 1 centimeter cube. This is what density is telling me. So if I want to use this conversion factor here, I know that 1.25 is with grams. I will put 1.25 grams and I want to transfer to centimeter cubes. But in how many centimeter cubes? If you see 1.25 grams in only 1 centimeter cube, I will put 1 centimeter cube. If I cancel grams and grams, my unit will be centimeter cubes. And then I will make the operation. That will be 500 times divided by 1.25. The answer will be 400. Remember again, let's use another color. We multiply times denominator, and the result we divide by the denominator. This is the first exercise when we have this kind of unit. So let's solve another one. This is a very common exercise in chemistry. So in this exercise, they can ask about concentration or number of moles or volume, if the other 2 units are given. This is a typical exercise. It says a solution that has a concentration of 2.0 moles over decimeter cube. So this will be the concentration, and a volume of 0.25 decimeter cubes. This is given the volume. Calculate the number of moles. Number of moles is the one that I need to calculate of solid present in the solution. So what I am doing is the following. So I will start always, as I mentioned, by the given number, 0.25 decimeter cubes. I have 2 moles in 1 decimeter cube. This is what the concentration is telling me. For every 1 decimeter cube, I have only 2 moles of the substance. So how I am solving this? So I will trace my line here. I will put decimeter cubes in the denominator because I want to get rid of that unit, and I want to put moles in the numerator because this is the one that I am looking for and this is the one that I want in 1 decimeter cube. Okay, now I cancel decimeter cubes and my answer will be in moles. So let's solve it. 0.25 times 2, well, we don't need the calculator for this one, that will be 0.5 moles. That will be 0.5 moles. Remember, 0.25 times 2 divided by 1. Sometimes it's that easy that it's only times 2 divided by 1, but knowing the conversion factor, you won't have doubts. Sometimes my students, they don't remember if they need to multiply it or divide it by 2 or by 3 or what is the mole ratio, and they get stressed about this. But now, conversion factors is the way to go. Let's do another exercise. Wonderful. I love this exercise because I will explain you how to use consecutive conversion factor. But in this case, we are using consecutive conversion factors. Okay, it will look at the beginning a little bit overwhelming, but if you go and you study this in detail, you stop wherever you need to stop and reflect about this, that will be very, very easy for you guys. So look at this. This is not for my chemistry students, but it's also something that my chemistry students can do, also for physics students, because we are talking about a speed. Even though rate of reaction is something that we studied in chemistry, concentration over time, but in this exercise we have distance over time, which will be applicable as you will solve it. It says the speed of light in a vacuum is approximately 3 times 10 to the power of 8 meters over second. The distance from Earth to Sun is 1.5 10 to the power of 11 meters. The question is, how long does it take light to travel this distance in hours? That's interesting because the unit is given in meters over seconds, and the given number is provided in meters, but the question is in hours. So that's amazing because this is how we will use conversion factors again with the given number 1.5 times 10 to the power of 11 meters. Now, if you see this number, it says 3.0 times 10 to the power of 8, and the unit is meters over second, meaning that for every second, record 3 times 10 to the power of 8. Now, I will do my conversion factor, and I will transfer the unit here. I know that 3.0 times 10 to the power of 8, because it's attached to meters. See, I put meters down. How many seconds? 1 second. If I solve this exercise here, I get rid of meters, and the answer will be seconds, and I divide it by the meter. The exercise is not stopping there because the question is in hours. Here, without putting any answer, I can continue. I know that this part is correct, so I can continue. If this is in hours, I need to transfer seconds to minutes. So I know that I have seconds and I have minutes. I know that we have 60 seconds in 1 minute. So I am canceling seconds, and so far, if I solve this conversion factor, my answer will be in minutes. But this is not the question. The question is in hours. I will put minutes down, and I will put hours. How many minutes in hours? So I will say that 60 minutes is 1 hour. And then some minutes go, and my answer will be in hours. That's good. Now I will take my calculator. It looks a little bit overwhelming because there are many conversion factors consecutive, but it's not that hard. So I will use my calculator, and I have 1 times 5 times 10 to the power of 11 times 1 is the same number, divided by 3.0 times 10 to the power of 8. And I have a number. I have 500, but I will continue here. 500 times 1 is 500. 500 divided by 6, it will be 8.33, but I don't stop. I just continue working with this one. 8.33 divided by 60. Again, that will be 0.133. hours. And that will be the answer for the exercise. I am using 1, 2, and 3 conversion factors. I multiply this one, then divided this one. The answer, this one divided by this one, and the answer and divided by this. If this is difficult for you, just stop the video and watch the explanation of how I am creating every conversion. Let's solve another one. I want to say hello to my DP1 and DP2 students. This is titrations. Some of you are asking about this and how to approach these exercises. So I explained it to you in class, in lessons, but here you will have the opportunity to stop and you will have the opportunity to see in your time and just try to understand in a different environment. So guys, look at this. We have this exercise and we have a titration. I love titrations because you guys can develop many skills, not only math skills and chemistry skills, but also you need to imagine a lot of things. I don't need to draw this one, the one that I always use to explain how we approach a titration exercise. So here we have this diagram. A 25 centimeter cubes of sample of sulfuric acid of unknown concentration is titrated. So meaning that here we have sulfuric acid, H2SO4, and we have 25 centimeter cubes. It's titrated with 0.125 moles over decimeter cube of sodium hydroxide. The average titrate at the end point is 32.10 centimeter cube. So this is the information that I will use to solve the titration. The question would be determine the concentration of sulfuric acid. So H2SO4, I don't know the concentration of this one, so that's the one that I need to find. Solve titration exercises is create a chemical equation. So here I have that H2SO4 because I want to see the mole ratio. 2NaOH producing Na2SO4 plus 2H2. I have used this equation a lot, so I memorize also the balancing. Always when you are approaching exercises, stoichiometry exercises or titration, make sure that the equations is balanced, okay? Now, this part, the starting point of this one will be 32.10 centimeter cube. So 32.10 centimeter cubes. I need to find the moles, but I will do something because we will need more space to solve this titration. You already know that concentration of sulfuric acid is the one that I want to determine. So here we have 32.10 centimeter cubes of NaOH. If I know that, because the concentration is in moles over decimeter cubes, I need to change centimeter cubes to decimeter cubes using conversion factors, right? So I know that 1000 centimeter cubes is 1 decimeter cube. So I cancel centimeter cubes, and then I have decimeter cubes. Then I am using the concentration in order to determine the amount of moles. The concentration given is 0.125 moles per decimeter cube, meaning that I can cancel decimeter cubes, and the answer will be in moles. But moles of what? Moles of NaOH. Now, if I see the coefficients in my equation, I have that 2 moles of sodium reacted with 1 mole of sulfuric acid. So I will know now that 2 moles of NaOH reacted with 1 mole of H2SO4. So when I cancel moles of NaOH and on moles of NaOH, I will have moles of sulfuric acid. Then I will multiply it because the question is the concentration of sulfuric acid. And the thing is that here, this is a special conversion factor because concentration is moles over decimeter cube. If I have moles already of sulfuric acid, I need to know what was the volume. If you see, 25 centimeter cubes was the amount of sample. So I will put only one here, 25 centimeter cubes. If I finish the exercise like it is now, the unit will be moles over decimeter cube. But I want to explain my unit in decimeter cubes, mole over decimeter cube. So I will use another factor and I will put 1000 centimeter cubes is 1 decimeter cube. So here I cancel centimeter cubes and centimeter cube. At the end, when I cancel all the units, I will use a different colors. Decimeters, moles of sulfuric acid. I don't cancel moles of sulfuric acid because I don't need to cancel that one. And there is no another pair to cancel it. Moles of sulfuric acid and decimeter cubes are the one that we have at the end. So this is moles over decimeter cube. So in this case, I will use my calculator now and I will start to do all the process. So I have 32.10 divided by 1000, first conversion factor, times 0.125, second conversion factor, divided by 2, third conversion factor, divided by 25. And then I need to multiply times 1000. The answer that I got here was 0.802, let's say, moles of sulfuric acid. What I did here, guys, remember, I just multiplied on this one, divided by this one, multiplied on this one, divided by this one, multiplied on this one, divided by this one, multiplied on this one, divided by this one. Yeah. The thing is that if I am multiplying or divided times 1 or divided by 1, so I don't spend my time doing that, I just use my calculator. I hope you solve this exercise by your own. I hope you and I hope you understand every of the conversion factors here. If you have any question about this or you will want to practice more exercise, please write me in the comments and I will support you with that. Okay guys, so this is the last part of the video. You will see that here we have some examples that you can use to train your conversion factor. I highly recommend you to practice this if you want to nail it. The benefits of this one is huge. Okay guys, so I highly recommend you. If you think that this part 3 was challenging, you go to part 2 or to part 1. In part 1 I am explaining from scratch. If you don't know anything about this, I even explain it was numerator and denominator. You will understand. Okay, so here we have the answers for the exercise that I just showed. So you just practice them and then you go to the answer. So this is my recommendation. Okay guys, so this is for this part 3. I hope you enjoyed, and if you like it, please subscribe and share with other friends that are studying science. Have a good one, and I see you in another video.